Hello everyone and welcome back to DSA plus AI agent series. In today's video we are going to solve LeetCode problem number 75 sort colors. This is a medium level array problem and it teaches us a very important technique known as a Dutch national flag algorithm. By the end of this video you will understand how to sort an array containing only zeros, ones and twos, how to solve the problem without using built-in sort function, how the three pointers approach works, how to complete the sorting in one pass using constant extra space. Let's first understand the problem. We are given an integer array called nums. Element in every element in this array is either 0, 1 or 2. Here 0 represents red, 1 represents white and 2 represents blue. We have to arrange the array so that all the zeros comes first, followed by all the ones, then all the twos. The sorting must be done in place. This means that we must modify the original array itself. We should not create any other another array to store the sorted result. We are also not allowed to use the language built-in sort function. Let's look at the first example. The input is 2021110. After sorting, the result should become 001122. All the zeros appears first, followed by the ones, followed by the twos. Now, let's think about the possible approaches. The first approach can be counting the frequencies. Since the array contains only three possible values, we can count how many zeros and how many ones are there and how many twos are present. For example, suppose this array is 202110 and in this array we have two zeros, two ones and two twos. After counting them, we can override the array. First, we will write two zeros in these indices, and after that, we will write two ones, and after that, we will write two twos. This approach takes linear time and constant extra space. However, it requires two passes. In this, in the first pass, we count the elements, and in the second pass, we override the array. The follow-up questions ask whether we can solve the problem in only one pass. The answer is yes. For that, we use the Dutch national flag algorithm. This is the optimal approach. It uses three pointers: low, mid, and high. The low pointer tells us whether the next zero should be placed. The mid pointers points to the current element that we are examining. The high pointer tells us where the next two should be placed. So this is our array. I am I am trying to explain that where the pointers will start. The low pointer will start from zeroth index. The mid pointer will also start from zeroth index. I am writing the mid pointer above so that we can understand easily. The low and mid pointer will start from the zero index and high is the last index of the array. So these will be the placements. Now let's understand the regions maintained by these pointers. I am about to draw four regions in this problem in this array so that we can understand it more easily. The first region is all the elements before low. So the first region will be all the elements before low pointer. So what will be that 0 to low minus 1, and we are hypothetically thinking that all these elements will be zeros. and the second region will be all the elements between low and mid minus 1. This region, the second region, low to mid minus 1, and all the elements between low and mid minus 1 will be ones. The third region will be mid to high, and the fourth region will be after high until the end of this array. And in this region, all the 2 will lies. And in this region, it can be anything like the all the unsorted elements. The elements from mid to high are still unprocessed. Like here, it can be anything. So our goal is to process this unknown region until mid crosses high. So we will move the mid pointer as our current element. So let's discuss that what will be the three possible cases of mid pointer. So let's discuss for every element at the mid pointer we have three possible cases. The first possible case is nums of mid can be 0. The second possible case is nums of mid can be 1, and the third possible case can be 2. Apart from that, there is no possible case because this array contain only 0, 1 and 2 elements. So so if mid element is 0, what will be the case? So in C, in this region we have mid here. So imagine that here is the first case. Imagine this 0 is here. So this 0, what is the correct place of this 0? You will say that in this region the correct place of 0 is correct, right? So uh, how to how to place this 0 to this region, how to swap it, whether we can put this 0 on the left side or we can put at the right side, right? But we have low pointer here in this region. So if I say that if I put 0 here, then what will be the scenario? You will say that you will see that this this region is sorted, right? This 0 is sorted and right. So if we swap the mid element to the low element, then it will be sorted. Let's swap it. 0 and 1. The low pointer is pointing to one element and mid pointer is pointing to 0 element. Let's swap it. 1 will become 0 and 0 will become 1. So we will see that this region is sorted, and you will see that here you will see that this region is also sorted, right? So the low pointer is here and the mid pointer is here, and if I increment low pointer to this uh, this element and mid pointer to +1, then it will maintain the region. We increment low because one more zero has been placed correctly, and we will increment mid because the current position has also been processed. So 0 will become in this region and 1 will go to this region, and again our regions are maintained. So what we did, if mid element is 0, we swapped low we swapped low position we swapped low pointer and mid pointer, and we incremented low by 1 and we incremented mid by 1, right? Now the second case, when the current element is 1, think that mid is 1, right? So uh, in the previous case, the scenario is similar, that this region is already sorted. This region is already sorted, we don't do anything, we will just increment the mid pointer. So this region will be maintained, this one will go here, right? And the region will be maintained. So we, in this second case, we didn't do anything, we did just we incremented mid only. The third case can be that mid element is 2. So think that mid element is 2 here. So what is the correct place of 2 here? In this region, right? So what we can do here, we can place this 2 on the rightmost side, or we can put it in between. So we will swap the mid element with high element. Then see that what happens. We will swap this 2 with high pointer. High pointer is pointing this last element which is unknown, and see that let's suppose high element is 1. Okay, or we can think that high element is 0. uh, then we will swap this with high pointer. 2 will become 0 and 0 will become 2. We swapped it, and we can see that this region is sorted, this region containing two elements. Then we will decrement the high pointer. Then what will happen, this region will be maintained, 2 will become in this region. Now we will see that mid is pointing to 0. If we increment this mid, then this region will be unsorted. So we observed a thing, that this element is not processed yet. We have to still need we still need to process this element, so we will not move mid further, we will still process this element. So in this case, what we did, we swapped mid element to high element, and we just decremented high pointer, we didn't move mid pointer. Let's recap the case 3. When mid pointer is 2, it belongs at the end of the array, or in this region. So we swapped mid element with high element. After the swap, we decrement high. However, we don't increment mid. Thus, this point is extremely important, because this element, the element coming from the high position, has not been processed yet. It may be 0, 1, or 2. Therefore, we must examine the element now present at mid again. Let's now perform a complete dry run using all these concept we deduced. Our input array is 2 0 2 1 1 0. Initially low is at 0 position, mid is at 0 position, and high is at fifth position of this array. So the current element at mid is 2. So the case 3, what it says, we have to swap the mid element with high. We will swap it. This will become 0 and this will become 2. And we have to we have to decrement the high pointer. It will become here. And we saw that mid pointer is pointing to 0 element, and it is not processed yet because it is coming from the high pointer. We have not seen what element is that, so we will not move mid further, as the third case says. Now mid pointer is pointing to 0 element, that is our first case. We have to swap low with mid, and we have to increment low pointer and mid pointer. Since low and mid pointer is pointing to the same index, we will the array will remain unchanged, and we will increment low pointer. Now low and mid pointer is pointing to first index, that is 0. Now the mid pointer is pointing to 0, then the again first case is here. We will swap low with mid, and again these pointers are pointing to the same index, then it will the array will remain unchanged. Now low is pointing to second index, and mid is pointing to second index. Mid is pointing to element 2, that's why the case is third here. We have to swap with mid and high. The mid element is 2, the high element is 1, so we will swap here. 2 will become 1 and 1 will become 2, and we will decrement the high pointer, and mid pointer will not be moved because the high pointer element is not being processed yet. Now the array is become 0 0 1 1 2 2. Now mid is pointing to element 1, the second case here. As we saw that if mid is pointing to 1, the array is already sorted, so we will just increment the mid pointer, will not do anything. Now mid is here. We will we will keep processing these iterations when mid is crossing high. So mid is again 1, and yeah, after seeing the second case, we will just increment the mid pointer to this index. Now we will see that mid pointer and high pointer is crossed each other. So we will stop here, and array, you can see that it is sorted. Now we will code this logic. I am initializing the three pointers: low equal to 0, mid equal to 0, and high to the end of this array. The unknown section of the array exists from mid to high, therefore the loop will continue while mid is less than or equal to high. In this case, we saw that if mid is here and high is here, so uh, we still did one iteration. When mid will cross the high pointer, then the loop will exit. Inside this loop, we checked the value at the mid pointer. So if nums of mid, according to our first case, if nums of mid is 0, then what we did, we swapped the low pointer with mid pointer. and we incremented low pointer and mid pointer by 1. This is our first case. Now if mid element is 1, then the second, according to the second case, we simply move mid further by 1 element, right? Otherwise the value must be 2, so we will swap it with the value at high and move high backward. And in this third case we didn't increment mid. As we discussed earlier that the element coming from the high pointer is not being processed yet, so we will not increment mid here. And this function did not return anything because the original array is modified directly, uh, and we have to do in place the swapping. Let's run this uh, code once. So the two things that we need to understand in this whole algorithm that we already discussed, I am repeating again, that why do we move both low and mid after finding 0? Uh, Before processing mid element of this array, all the elements from low to minus 1 are already ones. Therefore, when we swap the 0 at mid with the element at low, the element coming to mid position is either 1 or the same 0 when both pointers are equal. The element has already been accounted for. Therefore, it is safe to move mid forward. And the second important thing that why do we not move mid after finding 2? When we swap a 2 with the element at high, the element coming from the right side belongs to the unprocessed region, right? We don't know whether this new element is 0, 1 or 2. Therefore, we must check it again before moving mid. This is one of the more common places where people make mistakes. Now we do a complexity analysis. Let's now analysis that what will be the time complexity. It will be big of n, even though mid may stay at the same position after swapping a 2, the high pointer moves backward, right? Every iteration either moves mid forward or move high backward. Therefore, the total number of iteration remains linear. The space complexity will be big of 1 because we didn't use any additional array, we just used 3 pointers. Therefore, this solution satisfy all the requirements. We didn't use any built-in sort function. We didn't use any extra space. It sorts the array in place and it completes the work in one pass. Now, common mistakes that people can do. Let's discuss them. The first mistake is incrementing mid after swapping with high. Do not do this because the new element at mid has not been processed yet. The second mistake is using the condition mid less than high is the second mistake that people do, mid less than high. When mid and high point when mid and high points to the same element, the that element still needs to be processed, right? Because that mid element is not being processed yet. The third mistake is returning the array. We don't need to return the array. We are doing in place the processing. And mm, these three things we need to remember, that low manages 0, and mid scans the unknown elements, and high manages 2. And if we see these this region, these four regions, all three cases will be understood. Let's do a final recap. We used three pointers: low, mid, and high. If the current element is 0, we swap it with low and move both low and mid. If the current element is 1, we only move mid. If the current element is 2, we swap it with high and move only high backward. We repeat this process until mid becomes greater than high. This sorts the array in one pass, constant with constant extra space. The time complexity will be big O of n. The space complexity will be big O of 1. This technique is called the Dutch national flag algorithm, and it is useful whenever elements need to be divided into three distinct groups. Try solving the problem yourself before copying the code. Also, try performing a dry run with this array: 2, 0, 1. Understanding how the three pointers move is more important than memorizing the code. If you found this explanation useful, like this video, share it with someone learning data structure and algorithm, and subscribe to coinslive for more beginner friendly coding content. I will see you in the next problem. Thank you.